So let's get started. So, well, we already covered the most important topics for assignment 3, and let me open it. Where is it here? Yeah, we already covered most of the topics, which is texturing and camera movement. I'm gonna bring up the project so we can discuss it a little bit. Let's open our let me just check something here. Okay. Yeah, so I'm opening our previous project, and let's see what is the status. What is the state here? Sorry, I'm gonna run a server. Documents, CSC, and let me navigate to my directory. Should be here. Spring 2020 labs. We have lab 4. Okay, I'm gonna open our server. This is something that we discussed last time as well. We have to open server here, http.server, Python -m. So now we can access the project with localhost 8000 and open the HTML. What is the problem? Oh, what did I change? Wait, this is, okay. I don't know, there was a cache problem. Probably, yeah, but this is it. This is what we had. We ended up last time, I think our last feature we did last time was actually reading keyboard events, which is down here. I think those are the last lines we did. But before that, so we did this, which is like to read keyboard events, which is pretty much adding an event listener to the document, which is the page. So the entire web page is going to read events from the keyboard. And here we are just getting the keyboard name or the event name or the key name, printing it. And then we check if it's W, you print something, and we call this camera function. We discuss this idea of having a camera class. If you don't remember, and just quickly review it, we keep in this camera class a view matrix, a projection matrix, the I and the at point, and also the up vector. And here we have a setLookAt matrix that, setLookAt call that changes the view matrix when you create the camera. But whenever you change inside these functions here, you will be changing these values here. So these points and vectors. So every time you do change them, you're going to have to update your view matrix with this call. So we haven't done that, but and this is, I think, part of the assignment. We want you to figure out how to do this. This is just an example. And then also we talked about loading texture. We created this function load texture that creates an image, which is an HTML document or HTML image, and then loads this this image from the file system, creates a WebGL texture and send it to the shader. Okay, that's what we did last time. Today there's not much to talk about regarding this assignment. So what I plan to do was to talk a little bit about how to create a world, which is, I think, the last or the third topic of this assignment. And finally, I want to talk a little bit about performance, because there has been a discussion on Canvas, or on Piazza, sorry, about performance. And indeed, historically in this class, we have seen many students having issues with performance. And this might be, this assignment might be the one that you're going to have to kind of revisit your code and see, okay, maybe this is not that optimized, so I should get something fixed. And I'm going to give some ideas on how and where you could improve your code. I already have my assignment implemented, and we have a benchmark that you can compare with. And you don't have to have the same performance as me, but honestly, with this code we have been building here in the labs, we already have a pretty good rendering engine, which means that this actually code here that we created already handles a lot of cubes as it is. We don't have to change much. But if most of you have been using the Professor James code, which is to some extent easier to read, and it has more classes, it has a more structured architecture. But maybe now you can blend some of these ideas with his ideas, and then we can achieve maybe an ideal code that is going to both be structured and also it's going to run faster. So let me first talk about, sorry, let me ask you, any questions before we get started? Oh, let me put this back. Okay. So I want to start by making a class. I like doing this. I'm gonna make a class called world. And this class, the idea of this class that we're gonna define here a map. And this is gonna be kind of a tile-based map that we will use to specify cubes in the world. Okay? I'm gonna talk a little bit about it later, but we're gonna specify, it's gonna be a 2D array. So the world is represented, or the map, sorry, as a 2D array of walls. Okay. We're gonna create this later. And then I want to make a function here called build map that kind of takes this representation and actually creates geometries in the world. So this function parses the map and creates geometries in the world. Okay. And here what I want to do is something like this. I want to do this build map. As I create the map, as I create the world, I'm going to just build a map. The map is going to be hard coded here. Because this is just like a simple example, and this is going to be enough actually for the assignment. But if you want to go fancy, you can maybe read this map from a file, or then you could have maybe many maps, like levels of a game, you know, and then you could maybe have an option to finish a level, or maybe just select a level when you enter the world or something like that. This could be a nice extra for this assignment. But we actually, to get a B, I think you just need to get a full credit on this part of the assignment, you just have to hard code the map in your code. And I'm going to start hard coding something here, very small. I'm going to do something like this, 1, 1, 1, and then I'm going to open a new row here. I'm going to make a 4 by 4 array full of ones. I'm going to put some zeros here in the middle now. So imagine this as now a little map, right? Where we have this kind of entrance here, and those are walls. The ones are walls and the zeros are empty spaces. But imagine, so we are talking about a 3D world, right? So how to visualize this? So visualize this as, or this array in the, or on the z-axis, or the z-axis plane, right? So imagine that you put this grid here on the z-axis plane, and then whenever you see a 1, you're going to have a cube there, and whenever you see a 0, you just have empty spaces. It's going to be easier to visualize this as we implement it, but pretty much that's it. It's a 2D array that's going to be put on the z-axis plane. I'm going to actually write this down here. Map is represented as a 2D array of walls. This map will be placed in the XZ plane. Thus, a position, let's say XY in this map, represents a height Y, let's say Y. This is another way of describing this map. Okay, let's import this file. And see if it works. World. Now let's create a world here. Maybe before we can create a camera. Maybe let's create a world here. Create world. Now we can say world equals new world. Let's see if this doesn't crash or doesn't give us any problems. Okay, seems to be working. Nice. Now what I want to do is, well, I want to see the cubes in my scene. The problem is I'm going to need to kind of make a camera here to visualize this properly. Okay, and of course I don't want to give away the implementation to you, so I'm going to try to like do this. Maybe just change the camera to some default values and see if you can visualize this world. But actually, let's see. Let's try to place our camera, and let me see. So the camera is here, and its position is this. Let me put the camera back a little bit. Wait. Oh, sorry, not this. I want this to be -10. Yeah. Okay, this works. So now let's build the world, or let's actually implement this function here. So this function pretty much is, I'm talking about this part of the assignment now. We covered most of this. Now I'm talking about world creation, and I'm actually talking about this part. These two are fairly easy and fairly straightforward. I hope you can do this by yourself, by just implementing or adding a ground to this world in this class, and also a sky. So you could just have a world here, sorry, a ground, which is a new, we have a square here, right? In our geometries, we have a square, so you could have a square. It's saying here to use a cube. Some of you might not have a square class. So if you don't, you can use the cube. If you do, I think it's better to use a square because it has less triangles. And it's gonna do the same thing. And you need a sky, which is a box, which is a cube. And it's a very large cube. So I will let you do this part, but I'm gonna cover the basics of this world creation. So here we want to parse this map position by position, and whenever we find a 1, you want to place a cube in there, right? So this is a simple double for loop that goes from the width of the map, which is 4, and we can maybe define, give like here width and height. Or actually we could read. I think it's better if you read from the map. The width is the map dot, I think it's 0 dot length, and the height is, right, we have 4 rows. Oh, sorry, 4 rows, and this is, yeah, let's do this. And this is the height. So, oh, you can simply do this, right? Store the width and height in here. And then here we could just use width x plus plus. And then we do the same for the height. Oh, and something, actually I made a mistake because this is not height. We just mentioned here that this is on the xz plane, right? So that's called this position xz, because the y is actually the number inside, is a position. The position here, the number in the position is the y. So this is actually depth. This is depth. This is depth. And this is z. We're gonna iterate on the z. And then here we say let y equals to this dot map x to z. And then you check if y equals to 1, right? Or you can say greater or equal than 1, something like that. If you later, because later we're gonna actually have numbers that are higher than 1 here. And I don't want to do that. I want to leave that as the exercise from the assignment. So I'm going to keep maps with 1 or height just 1, but later you're going to have like 2s and 3s here, 4. I think it's up to, I think we defined the maximum height to be, let me see, 4. So this is the maximum height. So this, well, at least this is the height that we expect you to support. So your roll should be at least 32 by 32, and then here you would have, at minimum, you should support heights of size 4. Okay. So I'm gonna go back there, and here, this is the part I'm doing, right? And to keep consistency there, I'm gonna say if y equals 1, then we're going to create a wall here. And this is pretty much exactly how it's written here. Right, that translate. I'm going to translate this now to be placed in the right location in the world. Right, this is going to be X, Y, and Z. Okay. But Y is always 1. So let's do this. I'm going to actually keep this code here, 0. And I'm not going to do this. I'm going to just say equals to 1. And then later you add, you change this code to support heights greater than 1. But see that now we're gonna be translating this cube on the XZ plane. The Y is always the same. And we gonna store these walls in an array. And that's it. That's it for creating the walls, right? Let's see. Now we're gonna have to access these walls when we are rendering the world. We haven't rendered the world yet. There's many ways to do that. I think what I want to do is whenever you call build map, you create the walls and you can actually store the walls as part of the instance of this class, as part of the object. So yeah, and actually let's define this outside, because yeah, like this. So if you create the world, you have the walls defined, but they are empty. Okay. So okay, I think I'm fine with this. Let's see if this runs, because we are already calling this. So this is going to call this, and let's see if it works. We can print here W and see if you get. We should get 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. 10 prints. It looks like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, perfect. And they're all cubes, and they should have different translation matrices. Yeah, it should be fine. Let's try to visualize this. Let's try now. Let's render them. Let's render them in here. So we have our world here. And we have our rendering loop here. So here we are drawing only one square, which is this one. I'm going to comment that out. Yeah, we have this square here. We now have a world. So I want to do a for here for W, and we can, I don't know if you remember, but I talked about this notation of this of the for loops in JavaScript, and this is used to iterate on inside elements of an array. So we can do this world.walls. We can do let W of world.walls, and this is going to actually iterate, or W is going to get the values inside the walls array one by one. Note that if you use in, is also valid, but in iterates on the indices of this array. So you'll be 0, 1, 2, 3, 4, and this is actually in the values. So here we could call draw W, because W is a cube. So this should work. Ooh, what happened? Oh, wait, let's see. Draw W world.walls. See world.walls. X and Z, Z greater than depth. This is something. This should be. Oh, I see. I see. Our cubes. Remember, we didn't do this for the cube. I just realized we didn't do the UV mappings for the cube. So this means that it's kind of drawing a very weird cube. So what I have to do here is actually put some UV mapping here. I'm going to put all zeros for now. I don't want to also, as part of your work, you're going to have to place the right coordinates here. I'm going to put all zeros. It's going to give us some kind of weird, probably some brownish color. Remember, we did this UV mapping for the square and for the triangle, but we didn't do it for the cube. So we need to do this for the cube. Here you'd have to place the correct UV mappings for each one of these lines, for each one of these vertices. Okay, this should be a fix. Of course, now you won't see, yeah, we should see a flat, it's flat cube now because the textures are not correctly placed. What you can do is actually just borrow, if you borrow these values, yeah, this is better. So it helps us visualize. I'm gonna help, you should borrow these numbers for the cube. Because this texture is kind of symmetric, so it's gonna work just fine, I think. If you get this, at least it's gonna be better for us to visualize. If you have another texture that is not symmetric, it won't work probably. These numbers will be wrong. Let's see if it looks better. Yeah, it looks weird because the triangles have different, the mappings are wrong here. But anyways, we can see that. You can see the cubes in there, and you see the kind of the open space here. But there's a problem. I think this gap is wrong, right? The size, it should be larger. I think this gap should be larger. Let's look at our map. See, like we should see two kind of, at least the size of two cubes as an open space. And I know why this is happening. It's happening because when we translate our cubes, we don't consider the size of the cube. We're assuming the cube has size 1, which is actually wrong because the cube has size. So each side of the cube here has size 2, right? Because it goes from -1 to 1. And the distance from -1 to 1 is 2, right? So that's the what's going on here. So we have to consider that. I'm going to make a variable here, cube size. Or if you want, you can even maybe, if you want to make it here, it's also fine. Cube size 2. Cube size like this. And then here, we have to multiply by this scale. Or scale it, multiply by the size of the cube. Now you get the right, oops. Oh, of course, this has to be defined before. There you go. Now it looks right. Actually, let's move the camera a bit. Let's change the at position. So I put 1 here. I'm going to look slightly left. Not enough. Maybe 5. Too much now. 2.5. There you go. Now we can see that we get the opening spot here. And this is how you build the world. Now, if you had, if you had like greater heights here, you would have to change this if statement here to account for this height. And then what you want is actually to kind of stack cubes in that position, right? And that's your work. So you guys are going to do that. I'm not going to do it here, but this is the base for making the world. Okay, and with that, and then of course you have the ground, which is a square, and the ground is it's a square that you have to rotate it to also put it. You have to rotate the square to be on the XZ plane as well. It starts on the XY plane. Right? It starts here facing us. We have to rotate it down to get it on the XY plane. And the sky, you have to scale it by a very large number, for example, 1,000. And okay, yeah, so also something that is interesting is that we're gonna have to draw, right, these guys. We're gonna have to draw the sky and draw the ground. So make sure you also draw them in your rendering loop. So in here, you also have to draw the ground. So this draws the walls, but to do, you have to draw the ground and the sky. So you have to do this. And you could make a function that draws all of them together. Like we can call it draw, maybe make a draw function inside the world. If you want, you can have a draw function here that actually does that job. Yeah, we can, or you can just, what I like better, I think, is have a function called GetGeometries that returns return these are walls, but here concatenate walls are, we can make, let's make a geometries array and return these geometries. But this is concat this dot walls. And here can concatenate ground and sky as well. And then return geometries. Why is that? Why am I doing this? Because now we can in our rendering loop, where is it? Here. Now down here we can say world geometries equals to world.get geometries. And this has all the geometries of the world. It should have all the walls, the sky, and also the ground. And with that, we can just do this. Should work just fine. Yeah, I think this is nice. It encapsulates the geometries, and then you can add as many geometries as you want, like ground and sky. Yeah, I like this structure better, I think. But yeah, feel free to adjust the way you want. Okay, any questions so far? Okay.